are y'all given an assignment of work and then go to the drawings and determine how you're gonna do it? Or does a foreman take you and show you how he wants you to do it? Or do y'all regularly use the drawings on the job site?
Sometimes it just depends on who you work with.
Well, yeah, some people, they keep the drawings put up, but most of the jobs I've been on, I've had access to them.
So you're able to go and look and see where something is and determine your own routing for your conduit or whatever you're gonna do. So you're familiar. Yeah, I mean, I realize this course was a year ago, but y'all are familiar with use of drawings, and so our review ought not to be, I mean, it ought to be familiar. You ought to be remembering things in your actual workplace now that you learned from the course last year. So let's go through this, and in this module you had some performance work where you located a common wall and determined a dimension, determined the distance from access from the outside east wall to the center of the beam in the structure studio, and determined the elevation of the slab. So we'll do that.
Hi, I'm sorry, is this the electrical question?
Electrical code, journeyman's code.
Yes, sir.
It's
Across the way?
Yeah, I think it's,
I thought it was,
I'm gonna show you a place over here where I think it is. But,
thank you, I'm sorry.
That's 30 minutes. I feel like I already finished the test, but.
What's the camera for?
Well, we see that most. I ain't got a damn clue, man. Let's put in dots beside him, you know?
What it is, man?
What's the
That way he
camera
goes
for?
over it.
I guess somebody, what he said, somebody ain't gonna be here, they ain't gonna take the class, send it to them.
I remember.
Go ahead.
Weird, it sounds like they were trying it all the time, but these questions don't really involve anything I look at. It does. All the time. Not really. I mean, the dotted line.
All right, the drawings, it tells us this. There are 6 types of construction drawings: civil, architectural, structural, mechanical, plumbing, electrical, and fire protection. And most sets of drawings have all of those in it. And the civil plans or site plans, you might use that in parking lot lighting, or you might use it when you're bringing a feeder into the plant or something. But a civil plan shows the natural contours of the earth. The civil plan shows the natural contours of the earth. So if you're changing, anything being changed, if like a grade in the parking lot or something, it'll show how much dirt has to be cut or how much has to be backfilled to get it at the elevation they want it. But the civil plan will start out showing the actual contour, the level, different levels. So, and the structural plans, they are a set of engineered drawings used to support the architectural design. The first part of the structural plans go back to the beginning of the civil plan. We talk about the different types of drawing, Cuban. The civil plans show the natural, shows the elevation and natural contours. That pencil knows everything too. That pencil knows everything.
You failed my last test.
I thought that was the other thing.
Civil plan, now I'll just kind of go through what I said. You use them when you're looking at you're going for your parking lot lighting. You might want to check to make sure, that it's been cut to grade or something. Or you may have a ditch that you're bringing your feeder in through an area and you want to see, if they gonna grade, if you gotta dig a ditch and they gonna grade 4 feet off, and you wanna be 4 foot deep, you don't wanna dig your ditch and then have to go back out there and re-dig when they grade, so. You wanna use the civil plans to determine the elevation of the natural, and then, structural plans. Structural plans. It says the structural plans are a set of engineered drawings used to support the architectural design. The first part of the structural plan is the general notes. These notes give details of the materials to be used and the requirements to be followed. Structural plans will give details of the materials to be used. And then we go through those drawings, that you'll probably remember some of them that you looked at from when you were taking the class. And and all the drawings have, there's things that are on the drawings. It says the basic components of construction drawing. The title block, the border, the drawing area, the revision block, and the legend. And in the title block, you will have the company logo, the sheet title, the date, the drawn by, the drawing number, and the scale. So you will find the sheet title will be one of the important things that you find in the title block. And also, you have the legend. And the legend is one of the things that you'll use the most, and because it lets you know what those things stand for. It says each line on a construction drawing has a specific design and thickness that identifies it. Note that some lines may be used to identify off-site utilities. The identification of these lines and other symbols is called the legend. And we see some examples there. And then lines of construction. Now here's where you need to pay very close attention. Dimension lines establish the dimension, sizes, or parts of a structure. These lines end with arrows, open or closed, dots, or slashes at a termination line drawn perpendicular to the dimension line. Leaders and arrowheads identify the location of a specific part of the drawing. They are used with words, abbreviations, symbols, or keynotes. Property lines indicate land boundaries. Cut lines, lines around part of the drawing that is to be shown in separate cross-sectional view. Section cuts show areas not included in the cutting line view. Section cuts show areas not included in the cutting line view. And then break lines. Break lines show where an object has been broken off to save space on the drawing. Hidden lines identify part of the structure that is not visible on the drawing. You may have to look at another drawing to see the part referred to by the lines. Center lines show the measured center of an object such as column or fixture. Object lines identify the object of primary interest on the closest object. Abbreviations, symbols, and keynotes. And you know, if you're handling drawings, you know how they are used. Then grid lines, using grid lines to identify planned locations. A grid line system makes it easy to refer to specific locations on a plan. And I'll give you an example. Have you ever looked on a map, an area map, and it's got letters across the top, A, B, C, D, E, and then it's got numbers down the side, 1, 2, 3, 4, 5, 6, and you define a certain area. If you look on there, it'll say a street name, and it'll have like C5 beside that street name. Well, if you go to the C5, C and 5, you'll see a little area that's probably an inch or inch and a half square, and it'll show that street that you're looking for in that area. So that's what a grid line does on the drawing. If you want to know what's in a certain area of the drawing, you use the grid lines. A grid line system makes it easy to refer to specific locations on the plan. Then dimensions. Dimensions are part of the drawings that show the size and placement of the objects that will be built or installed. Dimension lines can have arrowheads or slashes at both ends, and with the dimension itself written near the middle of the line. The dimension is a measurement written as a number. Scales, all right. When you're scaling, how y'all scale with your pocket, with your tape measure, just scale out with your tape measure or a folding rule or something? Do they try to leave a scale, architect scale, and engineering scale on the drawing table for people to use? Because usually when they leave it there, it's gone in 15 minutes, somebody's carried it off, so.
Preston brought in the only one I've ever seen.
We got a computer that prints them off for us. So
Got what, Dominic?
we got a printer on the job, so we just print them all off
The printer's pretty
individually.
awesome.
Yeah.
Pull up whatever area.
Oh, all right.
That's all for you. That's pretty cool.
We got an architect scale and an engineering scale. An architect scale has its dimensions in fractions of an inch or foot. So the architect scale is often used to create construction drawings. And it, you know, let's say a half inch equals this many feet, or an inch, or a quarter inch. You don't have your books with you, but and I understand that, but you could look on here and see that. And then the engineering scale, which you would use mostly with the civil portion of the job, out on the, like the big lengthy thing. So the engineering scale is used mainly for land measurements on site plans, which means the scale must accommodate very large measurements. The engineering scale is set up as multiples of 10, and the measurements are taken in decimals. So we'll have it for each scale, the measurement can represent various units derived from that scale and a multiple of 10. For example, on a 10 scale, 1 inch can represent 1 foot, 10 times decimal 10, 10 feet, 10 times 1 point decimal 0, or 100 feet, 10 times 10 times 1 0 point 0, and so on. So if a measurement on the drawing, is if say 1 inch equals 10 feet, a half inch equals 5 feet.
They said, you touch
All
your
right.
hand, where it scratches your back.
Anybody have any questions or need to go back to anything?
Yeah.
If y'all will exchange the drawings, I'll give you the answers. Everybody ready? Anybody need any- another minute? Plans used for work that has to do with construction in or on the earth are called
Civil plans.
civil plans. The material to be used for the walls would be found in the,
Structural plan.
what information in a drawing's title block identifies the project?
Sheet title.
The information needed to identify lines and other symbols on the construction drawing can be found in the,
Legend.
break lines are used to show that,
Only part of an object is represented to say space.
in the alphabet of lines, an area not included in the cutting line view is shown with
Break lines.
section cuts.
Section cuts. Damn,
I know, I missed it.
I'm going with you. I trusted you.
Grid lines are used to
Make it easy to refer to specific locations.
make it D. A dimension is a measurement that is written as a
Number.
one way that an engineer scale differs from an architectural scale is that the engineer scale is
Based on units of 10.
if 1 inch equals 10 feet, the arrow on the engineer scale in the figure above indicates a length of
5 feet.
5 feet.
Right? There's a lot of passing around paper.
Here, is this Mr. Lipscomb?
Yes, it is.
The lip skin.
Let's go, damn it, let's go.
Damn it,
I like how you,
the
I like how you marked it out. Put an X on it and then circled it around one all at the same time. God, money.
I want to let you know, hey.
He's like, hey, you fucked up right here, baby.
Yeah. Surprising, you didn't use big red marker
I know.
around it.
Well, I was just gonna change it for you and not mark it wrong, but then I forgot they gotta go through this.
At least make it like I was there. Take me home.
All this orange is hurting my eyes.
Send us home.
Go Tigers.
I like that garnet.
Oh,
Don't
yeah,
you?
It hurts so much, send us home.
All time.
You got Carolina man? Get out of here.
Carolina. What? Ugh,
Listen,
ugh.
are they ranked in basketball? I don't keep up with basketball. Clemson, I thought we're Clemson 7. I didn't know that sports.
So,
What's going on, Kiwi?
You got another test to do and then,
like tomorrow? Let's do it tomorrow. When we're not here.
Yeah, tomorrow.
if you have your electrical book,
I don't know.
and you're halfway through, a little over halfway through when you get your cord. Let's do something right quick. Where you, I'm on.
Here. Oh shit, this
We'll get y'all to do this, or I'll just show you.
Not no problem.
Y'all say, oh, we remember that. Finding that middle wall, do y'all remember finding that wall? Yes.
Yeah,
Okay.
I remember that
And
one.
this dimension right here, you remember when you did that?
Every little
Find
bit
that
of it.
dimension?
Every little bit.
Okay. Let's see what else we got.
When we weren't here. Yeah.
I mean, y'all already done this, there's no need to have to do it over.
Every day.
Where they got you?
The wall common to both interview rooms. This is an interview room, and this is an interview room, so
Pretty big, yeah.
that red line right there would represent that, wouldn't it?
Kiwi.
Okay.
Where they got you at? Where they got you at?
Overall width of the structure studio,
Travis.
add those lines right there.
You got Travis?
The outside east wall is the center of the beam in the structure. Everything right there.
I've been up in the area.
And the elevation of the
We got there
slab.
with Brian Fowler.
Yeah.
Was he a friend? Yep. We're gonna do like racks 70, 80 foot up in the air.
You see Travis tell him not to pussy bush.
Huh?
Tell him, damn it, boy, not to pussy bush him.
What, Casey Mall?
No, he, man, you know how he is coming up. He's going
We
around
lost
there,
him while we were
Marley
doing
Lily talking about pussy bushing.
Really?
Yeah, he's like, I can see his blood out, take that hand, bone in it, you stick that bone
Yeah,
under in there,
I
stick
remember.
that bone out, you get yourself a pussy bushing.
Y'all remember concrete levels? Y'all remember the concrete levels, right? Yeah.
What? Yeah. Oh,
Concrete
yeah.
levels.
Damn it, boy. Sorry,
What the hell?
Circulation drawing.
I'm looking down.
I just dropped that. I was like, nope, I'm done.
Yeah.
It is kind of cool though.
Here,
This is great.
there's the elevator drawing, there's a. That didn't work.
What do you call it? Like,
You ever use this?
Yeah,
Do it
well,
on the ground?
we have walking boards on the bottom right there,
Ain't never had.
but I had to go over to get a bundle of 1 inch.
Just underground, like I said.
All right, get your electrical level 1 book.
And today, it's raining like crazy. We're up on the lake, on the very top side, and we had to come down because they suspended the air work for like a few hours. Because it was 30 miles an hour wind.
I just leave it calm down.
Huh? When you,
We're gonna spend a little bit of time on this.
sorry, that'd be not easy.
You have some questions that require calculations.
What's that from? I know that noise from somewhere.
It's an Android phone.
No.
I'm sure that's where you know it from.
I'm fucked up.
I know it from somewhere.
All right, outlet boxes. Outlet box is a metallic or non-metallic box installed in an electrical wiring system from which current is taken to supply some apparatus or device. So, switch box would be an outlet box, receptacle box would be an outlet box.
Oh.
And then there's different types of boxes. Has anybody here done explosion-proof work?
Yes.
Yeah.
Okay, all of you have, y'all up around that hospital, I imagine there's areas in there where they
It was at the sprinkler plant.
Yeah. We haven't done anything at the hospital like that
had,
yet.
That room is not an explosion proof room.
No, it's
No,
Fucking-
not at
there's a
all.
fucking
It's
heater in
considered
there.
that.
They got an open flame heater in that damn room. That's explosion proof.
All right.
You can fit me this shit on completely.
We went through
Don't
these.
fill 'em with that shit, though.
All right, octagon and round boxes on page 4. Octagon and round boxes are used for wall-mounted lighting fixtures. Now, I'm gonna just make a mention of something about a round box and an octagon box right now. A round box cannot be used with conduit.
No.
Now, why is that?
The connector won't go in it.
It won't, the lock nut won't pull up because it's on a curved surface, so, but I'm sure there's places where there's some, usually they have a cable clamp in them and, all right. Says figure 5 on page 5 shows a box, a shallow box being used with a fixture. And that fixture has a cover that allows space for making it up. So the National Electrical Code section 314.24A requires that this and all boxes have a minimum depth of 1/2 inch. All junction and outlet boxes are, but you can't use an outlet box for, without a raised cover or so all of them, 1/2 inch is a minimum depth of a box you can use on the job. And we got square boxes, and square boxes are either what? 4 inches square, or they're 4 11/16 square. So you can determine by the area inside the box, you can determine which one you need to use. And then device boxes, and we see on page 6, we see some different device boxes, nail up and nail up plastic, nail up metal, and different types of nail up boxes. And then on page 6, figure 6 shows a square box with an extension ring. Now what that extension ring does, or what I always call it a mud ring or a plaster ring, what that does is add space to that box so you can get more wires in it. Masonry boxes, which are used in flat, says used as in flat slab construction jobs. These boxes consist of a sleeve with internal ears, external ears, and a plate that is attached after the sleeve is nailed to the deck. So y'all probably done some of that where you're putting floor boxes in a slab. And boxes for wet and damp weather. They make boxes that rain tight or water tight or weatherproof. And then size in outlet boxes. Now this is something you need to pay close attention to, because there's going to be some questions concerning things that take up space in a box, and how much space do they, how many wires do they eliminate from the normal count of wires that can be allowed there. It says, in general, the maximum number of conductors permitted in standard outlet boxes is listed in the National Electrical Code Table 314.16a. These figures apply where no fittings or devices such as fixture studs, cable clamps, switches, or receptacles are contained in the box. So that should tell you right there that if you have one of those things in there, or more than one, that you're going to have to decrease the number of wires in the box. So obviously, in all modern residential wiring systems, there will be one or more of these items contained in the outlet box. Therefore, where one or more of the above mentioned items are present, the number of conductors is reduced by one less than that shown in the table for each type of fitting, and by 2 for each device strap. So if you have a box that allows you to have 8 wires in it, and you have a switch in that box, you're already down to 6 wires. If you have a 2-gang box, and it allows 8 wires, and you got 2 switches, you're only allowed to have 4 wires in that box. And one way to overcome that would be to either put a box extension or a plaster ring on it to give you a little more space. But remember that each device strap counts for 2. So if you got a receptacle in a box, you lose space for 2 wires. If you got a switch in a box, you lose space for 2 wires. It says, for example, a deduction of 2 conductors must be made for each strap containing a device such as a switch or duplex receptacle. All right, it says this, that last sentence there says, also, each looped conductor over 12 inches used in the box counts as 2 conductors. So if you got a wire that's going into the box and out, that counts, even though it's just one wire, it counts as two wires. If you look on page 9, figure 10, it shows several things that affect what you must deduct to make a box work. And listen, it's hard, like, how about putting a ground fault receptacle in a box? Say a handy box or just a sectional device box. I mean, it's hard to get the thing in there. I mean, if you got wires that are, when they're terminated on that thing, you got to fold them up in there, and you got to leave 6 inches of wire for the inspector. I mean, that excess wire got to fold up behind that thing. So you need to put a box that's deep enough to take that, or you need to change, not use a sectional box and use a 4-inch square box and a plaster. And that's probably what y'all use for most y'all's work anyway, right? A 4-inch square box with a plaster in it. But anyway, it's good to know this. It says, figure 10 shows typical wiring configuration and devices that must be counted as conductors when calculating the total capacity of outlet boxes. A wire passing through the box without a splice or tap is counted as one conductor. Now that is true unless what? It's got a 12-inch loop in it. If it just pulls straight through, it counts as one. But if it's got a, what does it tell us over on the other column? Each loop conductor over 12 inches used in the box counts as two conductors. Alright, so therefore a cable containing two wires that passes in and out of an outlet box without a splice or tap is counted as two conductors. However, a wire that enters a box and is either spliced or connected to a terminal and then exits again is counted as two conductors. So if you got a wire coming in and a wire going out, it's the same wire, but you're making a splice in that box, that wire will be two. If you don't have a splice in the wire, if it just pulls straight through, it's one conductor in that box. If it splices or terminates, it counts as two. In the case of two cables that each have two wires, the total conductor count will be 4. And also that no matter, remember this just for your own information, no matter how many grounds you have in a box, they count as one wire. So you don't have to count all the ground wires, you just count. If you got a ground in the box, it's one wire. Now, also remember that every box must be grounded, every metal box must be grounded. So you'd have, say if you had four conduit going into a box, and each conduit had a hot and a neutral going into that box, and a ground wire, you'd have, when you tap that up, you'd have 5 grounds. You'd have the one that's bolted to the box, and one out of each wire, or each cable coming in, so you'd have 5. But it would only count as one wire. So if your box would allow 8 wires, the depth of the box, the dimension of the box would allow you to have 8 wires, you'd still have to add a plaster ring or a box extension to tap up in that box, or to utilize that box. And if you were putting switches in it, you'd surely have to have it, because you'd have 8 conductors, 9 conductors counting the ground, and you'd have a switch which would deduct 2, or a receptacle, each one would deduct 2. So it's just something to think about. And it, you know, I know those times when you're not in charge of how many pipes go in there. You may be in charge of pulling the wire in, and you got a box there, and you got to get the wire in, and it's too late to put a plaster ring on it. Why? Because it's already a finished wall. It's got a say a 1/2 inch plaster ring, which would give you just a nominal extra space, and you needed an inch and a half plastering or something, or you needed a box extension with a plastering. But I mean, you got to get the wire in there, and then, even though it's a violation of the code, you gotta get it in there, or else you gotta tear a bunch of somebody else's work out to do it. All right. Okay, then, looking at requirements for receptacle location. And if you look, listen, let me just give you this. At least one receptacle is required in each laundry area, at least one. All right. And normally, I would put, if I were doing it, I'd put two, because some people do iron, and you might, if you have a little laundry area, you're gonna have a washing machine that's gonna need a circuit, and it'd be behind the washing machine, and if you need to iron, you'd want a receptacle out where you could get to it. But anyway, you have to have at least one. In the kitchen, on the kitchen counter, you have to have two. In a kitchen, you have to have two receptacle circuits, 20-amp receptacle circuits, and if they're within 6 feet of the sink, you gotta have a ground fault receptacle, or they gotta be backed up by a ground fault breaker. But remember that at least one receptacle is required in the laundry area. Did we do the section review? Y'all got your books? A receptacle is usually housed in it's got 4 choices: pull box, round box, junction box, or device box.
Device box.
All right. If a box can hold 8 number 12 wires and contains a cable clamp, a switch, and a loop conductor that is 13 inches long, the maximum number of additional wires is 3. All right. Good work. A box installed in a wet location must be
Listed for the application.
all right. Good. All right, let's move on to section 2. Sizing, pull, and junction boxes. And I think we need to spend just a little bit of time here, because so we got a box. Okay, that's one box. All right. Okay. Sizing, pull, and junction boxes. Pull boxes should be as large as possible. And I agree with that with some reservation. I mean, you could put one up there that'd be much, much bigger than it needs to be, but, I mean, they're talking about within reason. Workers need space within the box for both hands, and in the case of larger wire sizes, workers will need room for their arms to feed the wire. NEC sections 314.28A through E specify that pull and junction boxes must provide adequate space and dimensions for the installation of conductors. For raceways containing conductors of number 4 or larger, and for cables containing conductors of number 4 or larger, the minimum dimensions of pull or junction boxes installed in a raceway or cable run shall comply with the following. All right, one of the things we learned right quick, bigger than number 4, number 4 larger. It's okay. In straight pulls, the length of the box shall not be less than 8 times the trade diameter or metric designator of the largest raceway. So we've got a box here, and we got a 3-inch pipe and 2 1-inch pipes coming in one end, and a 3-inch pipe and 2 1-inches going out the other end. How long does that box have to be? Yeah, all right, what does it say? What our rules say to us?
16, 24,
In straight pull,
28.
the length of the box shall not be less than 8 times the diameter of the trade diameter of the metric designator of the largest raceway. All right, so we want to remember 8 times, and we want to know the diameter of the largest raceway. The diameter of the largest raceway is
3 inches.
all right, so 3 inches, so 8 times what?
3.
All right, and that is
24.
24 inches. So this box has to be 24 inches long. The 1 inch, the 2 1-inches don't add to it. All right, you got it on a straight pull. It's the diameter of the largest conduit going into it. It's 8 times, all right? So, all right, now, let's look at this one. Got the same run of pipe, but we're going in, we're gonna go up somewhere and we gotta get around the corner, and instead of going in, going straight through this box and putting 90s on the other side of it, we're in a situation where we need to turn our wire in there. All right, now what does it say about that? Where angle or U-pulls are made, the distance between each raceway entry inside the box and the opposite wall of the box shall not be less than 6 times the trade diameter or metric designator of the largest raceway in a row. So what's the largest raceway in that?
3 inch.
All right. This distance shall be increased for additional entries by the amount of the sum of the trade diameters, metric designator of all other raceway entries in the same row on the same wall of the box. So we've got a 3-inch and what? A 1-inch and a 1-inch. So 3 plus 1 is 4, plus 1 is 5, times what?
6.
Say it loud.
6.
6. So what does this box need to be? 30 inches square, right? And now, I mentioned this as we were going over the text. You also will have some influence of what manufacturers make, standard measurements. You can have a box made in any size you want, but if you go into the supply house to buy one, or you just order them, they're going to have boxes of, so probably you would end up with a 36 by 36 here. Okay, so if you go in and turn out an angle, a wall on the side wall, it's 6 times the diameter of the largest raceway plus the accumulated total of all other raceways. So if this had, say if it had 2 or 3 more out here, 2 or 3 more pipes, say if it had 5 1-inches, you'd have a 3 inch, and 5 1-inches would be 8 inches, and it'd be times 8 and 6/8 is 48. You'd have to have a 48-inch box. It would just get exponentially bigger as you added conduits in the same wall. All right, so you're gonna have to figure one like that. You'll need to, and you need to do that, be able to do it on the job site. You wanna, when you're on the job site, their criteria, the text criteria said use as large a junction box as is possible. But there's factors there. I mean, you don't want to put one up there as big as the trunk of an automobile and have 3 pipe going in and out of it. I mean, you're gonna have a cost factor involved. All right, so remember, I'm gonna go over this one more time. In straight pull, the length of the box shall not be less than 8 times the trade diameter or metric designator of the largest raceway. 8 times the biggest conduit. Where angle or U-pulls are made, the distance between each raceway entry inside the box and the opposite wall of the box shall not be less than 6 times the trade diameter or metric designator of the largest raceway in a row. The distance shall be increased for additional entries by the amount of the sum of the trade diameter of all other raceway entries in the same row of the same wall of the box. All right. I said also, where angle or U-pull are made, the distance between raceway entries enclosing the same conductor shall not be less than 6 times. And transposing cable size is the raceway size, the minimum trade size required the number of trade roads shall be used. All right. Installing pull and junction boxes. Pull boxes installed at convenient intervals will relieve much of the strain on the conductors. I mentioned this earlier to you. To me, if I were installing this run of pipe, I would go out here and I'd put me a 3-inch 90, a 1-inch 90, and a 1-inch 90, instead of putting a junction box and pulling that wire around at right angles out of that box. You say, well, why? Well, if you have a proper, like a tugger, and the run is not too long. Now, I'm qualifying this now, and the run is not too long, you can pull that wire straight through that box right there. You don't have to have an extra man once he gets up there and bumps it in to the pipe on the other end. He's just pulling it right along. If you do this, you got to have a man or two. You got to either pull and slack out and got a man on the floor and have him feed it back up. I mean, it lessens your manpower and you're letting the tugger do the heavy part of the work. And now I realize some runs are so long, but to me, it's never good to pull at right angles. I mean, it's just it's labor intensive, it's more labor intensive, it's just requires more help. Actually, if you had a good strong tugger and 2 good men, 2 men could pull them runs right there. 2 men won't do that one. So, at the minimum, you'd have 3, and the man right there, you'd work him to death, getting that wire around the corner. So you'd want to be on that end or that end. You wouldn't want to be right there in the middle. So something to think about. But remember how to calculate it. All right, on page 21, we got some 2 questions. A straight pull contains two raceways. One of the raceways has a trade size of 3 inch and one has a trade size of 2 inches. The length of the box must be,
24 inches.
how did you get that? 3 inch, the biggest conduit is 3 inches times
8.
8. You just don't calculate the 2 inch, because it's a straight through box. All right? If possible, pull boxes should be installed.
B, the H location for east.
Right. Now, normally in construction, in commercial construction, and you're gonna have to work it off of a man lift or, and a man would have to have a lift right there. He'd have to be on top of an 8-foot ladder. I mean, an extension ladder, or not an extension, an A-frame ladder or something tall enough to get up to that. It'd take a man twice as long, a crew of men, twice as long, twice as many man hours to pull through that box as it would to pull through a straight pull. So keep that in mind. All right, I want you to go ahead and do the section review, the questions on page 22. How many of you have your book? Everybody? Page 22, there's 10 questions. Go ahead and go through them, and if you need to go back and review it, it's text, you're welcome to do that, but you got 10 questions you need to get the answer to. I think we've discussed enough for you to be able to answer those questions.
So y'all get the rest of it.
What's up, man? What's number 10? Number 8? Number 7? I guess, 35 on
Number seven is the one.
Where's the audio zone?
They're recording the shit out of us. You got the fucking light on.
Fuck this damn shit.
We don't give a fuck. We get recorded on a daily. Look at Trevor.
Conductors in a box, you must deduct blank conductors for the total. I was sleeping for the equipment.
I think it's,
Second.
Chevron. It's one, but I think all grounding is considered.
yeah.
You did say that. You did. You're right.
Okay, let's go over these quickly and then we'll take the test. The maximum weight allowed by the National Electrical Code when the ceiling fans are mounted directly to an approved unmarked box is
35 pounds?
35, right? Square metal boxes are available in sizes of 4,
411, 60.
411, all right.
Good job.
A box installed under a roof open porch is considered a
Damn location.
good. How many conductors must be deducted for each strap mounted device in a device box?
2.
The capacity of an outlet box can be increased by using,
Raised cover.
right. A conductor under 12 inches long running through a box counts as a conductor equivalent of
2?
under 12 inches.
Under 12. You even got me.
Right. If there are 4 equipment grounding conductors in a box, you must deduct how many conductors from the total allowed?
1.
Good. Factors to consider when installing boxes are covered in NEC sections
B.
B, 314.15 through 314.430.
Guessing right here.
If the largest straight diameter of a raceway entering a pull box is 30 inches and it is a straight pull, the minimum size box allowed is
B. B.
24 inches. All right. The depth of a pull box with a conduit runs entering at right angles. The depth now, we didn't discuss that, but maybe we should have. Need only to be deep enough to permit the installation of lock nuts and bushings. Okay, I'm gonna give you the test.
I thought this was the test.
I'm not.
I'm pretty sure I
3 tests tonight,
I'm
yeah.
pretty sure I just failed.
Failed everything.
All of it.
0. Straight 0.
Damn it. I gave you 100, you still failed.
I had a 0 freshman year.
That was a little bit.
They wouldn't even get to use
Did you give me that, you still got a test?
it. I almost forgot about it.
Thank you.
20. When did we get our goals in, right? Last year, on Facebook, it showed up a year ago today. Got our-
It was like what? It was March before we got our stuff?
No, a year ago today. Yeah, I see He's on job site, you gotta get card off your ambulance.
Today?
Yeah, you don't know.
Oh, did you hear about that, Mr. Neely?
What's that?
Huey, you know Huey, Jonathan Huey?
Who?
Jonathan Huey?
Yeah,
He had a seizure today at work.
really?
Yeah, they had to card off. Luckily, we're working on a hospital that's already existing, so they came pretty quick, but.
What did they, I mean, did they get any prognosis? I mean, did they know what it was, or?
We had heard it.
They said they were gonna run some tests, but they never did.
Hmm.
I had never heard of that.
You said he don't even remember how they know.
So he was awake and talking and shit when he left? Yeah.
Yes, probably he was good.
What?
Hey.
All right, you ready?
Are you gonna say here you go, or? I'm just saying, that's what he's gonna say to do. I don't fucking want to, I don't really give a
Oh,
fuck.
that's fine. They get paid.
Yeah. Ah, this shit. You okay?
Is that the bump right there?
Don't do it.
I'm
He'll
not
play
poking
you.
it. This thing, is that the one right there?
Yeah, you get away and 50 bucks.
What the hell?
He was
I mean, if you touch it, and it leads to him hitting you, I'm gonna pay $50, cause that would be worth it. If you touch it, you'll probably get it. Either way.
I get $50.
All right, everybody through? Not yet.
Person, probably.
Let me ask you a question while we're getting finished. Mr. Robinson did not put module 6 on your retest but module 6 is rigid. It's an elective on the core curriculum. You can either study it or not, test on it or not. He didn't put it there, and so that would mean that we would have 3 tests left to be finished with core. But in my mind, it's an opportunity, it's a short course. I believe it's 10 questions on the test. There's one hand signal on the performance task, and it'd be quick to do. And then, if in the progress of your apprenticeship, you wouldn't have to take it again. If it ever shows up again in anything you do, you've already completed it and you won't have to take it again. So I'm gonna leave it up to y'all. Do you wanna do it or not do it? Is this gonna mean one more test and another week to?
Might as well be here anyway, right?
Yeah, might as well go ahead and do it.
Yeah, I would, good. That's the way I thought. I mean, it'd be just valuable to you, so. Is everybody ready to trade papers?
Yep.
All right.
Mhm. What's it like? You got a straight view in your here.
That's everywhere, dude.
It's black. And here's brown, it's black.
I'm going this Friday, actually, I'm actually going this Sunday Friday to get all, it's probably trimmed off. Me too. Well, no, I'm not talking about the food, I'm talking about trimming everything way the fuck down.
All right.
Pickens it doesn't.
Thomas will be disappointed.
Make sure you